Hello everyone and welcome to Contemporary Math. This is 3.3 Truth Tables for Conditional and Biconditional. So we're going to continue our trek with truth tables for these two topics today. The conditional is a little bit tricky, so just hang in there and we'll see how it goes. So the conditional, the statement if P then Q is true in every case except when P is true and Q is false. So what this is telling me is when I see T arrow false, this is the only time where this is going to equal a false statement. Any other combination is going to be true. So just trying to understand this. If you get an A, then I will buy you a car. Okay, so here, the answer, true or false, answers the question, did I keep my promise? So let's go ahead and just talk about case 1. And you'll recall from last section that our first case is P is true and Q is true. So if P is true, that means it was true that you got an A. If Q is true, that means it's true that I did buy you a car. So in this case, did I keep my promise? And the answer is yes. Therefore, this is going to be a true statement. Okay? So when we get T, arrow T, that's going to equal a true statement. Now in the next case, remember it was P is true and Q is false. So let's go ahead and take a look at our cases again. It says if you get an A, well, it's true, so you got an A, then I will buy you a car. Well, this one is false, meaning I didn't buy you a car. So you held up your end of the bargain, and I did not hold up mine. Okay? Did I keep my promise then? Well, the answer is no. So therefore, this is a false. Okay? So when we get this, we'll have T arrow F. That's going to equal our false statement. So let's take a look at case number 3. And this is probably going to be the toughest one to wrap your brain around. So remember, case 3 was P is false and Q is true. So let's see what it means in our example. So if you get an A, this is going to be false, which means you did not get an A. Then I will buy you a car. So buy you a car is true, meaning I bought you a car anyway. So here's the question, did I keep my promise? So in this conditional statement, does it say anything about what happens if you don't get an A? Well, no, it doesn't. So as soon as you don't hold up your end of the bargain, I'm then free to do whatever I want. So I can still buy you a car if I want to, and I ended up keeping my promise because you didn't get an A, therefore I can do whatever I want. So this is the weird one where this becomes a true statement. Okay, so false arrow true is going to equal true. Okay, and a lot of times I think about this case as the grace case. So in God's law, he talks about, the only way to eternal life is by being perfect and following the law perfectly. So, do we follow the law perfectly? No, false. But does God still grant us eternal life? That answer is true. In Christ Jesus, he does. And so this is our grace case. We don't follow the law. We didn't hold up our end of the bargain, and yet God still gives us his eternal riches. And there's our true statement right there. For the last example, okay, the last case is going to be where P is false and Q is false. So let's think about this here. So if you get an A, so that's false, you didn't get an A. Then I will buy you a car, that's false, so I didn't buy you a car. You didn't get an A, I didn't buy you a car. Did I keep my promise? Well, again, as soon as you don't hold up your end of the bargain, I'm free to not buy you a car. And so this one is also a true statement. And so it rounds it out. False, arrow false, is going to equal true. So again, if P, then Q is true in every case except when P is true and Q is false. And you can see that right there. All right, let's move on. To biconditional. Here, the statement P, if and only if Q, is true only when P and Q have the same truth value. So these have to match truth values for it to be a true statement. Okay. So let's take a look at our cases here. We can fill these out: true, true, false, false, true, false, true, false. Now the question we're asking here is, do they match? And if they do, then it's a true. Okay? So here, T, if and only if T, that is matching. So we get a true statement. T, if and only if F, that's a false because they don't match. F, if and only if T, that's false, they don't match. Here, false, if and only if false, that equals a true statement. So here is how you figure out biconditional truth values. Now, the biconditional statement really means if P then Q and if Q then P. So it's a biconditional. You can see condition going one way and the condition going back the other way. So let's go ahead and do this truth table here and just compare it with our answer. So we have true, true, false, false, and true, false, true, false. And let's go ahead and figure these out here. So we have P arrow Q. So that's going to be true in this case. So if true, then true. Here, if true, then false. That's our false statement. If false, then true. That's true. And if false, then false. That's also true. Now we'll do this one. Switch it around. If Q, then P. So now we're starting with Q. So it's if true, then true. That's fine. If false, then true. That one's okay. If true, then false. That's the only one that's false. And then here, if false, then false. That's got to be true. Now just recall with our conjunction or and, they have to both be true. So here in the first case, they're both true. So we'll get true there. In our second case, the presence of false makes it false. Here in the third case, the presence of false makes it false. And in our fourth case, they're both true. So this is true. Okay. Now, if we go ahead and compare this column and this column, what do you notice? Well, they're the same. And we're going to talk about this a little bit more later, but truth tables with the same truth values are equivalent. So it's really two ways of saying the same thing in this case. All right, let's move on. So in logic, we get a few specific types of statements. This first one is called a self-contradiction. And this is a compound statement that is always false in every case. So it's a self-contradiction. It always turns out to be false. So let's go ahead and show this here. We can fill out our cases. Okay. And we have P if and only if Q. So remember, this is true when they match. So first, what we want to do here is just repeat the P repeat the Q. Make sure your F's look like F's. And then P, if and only if Q, is true when they match. So here they match, they don't match, they don't match, and they match. Okay. So this now is our column that's still alive and in play. Let's move over to the other set of parentheses. We're going to fill out our P, which is true, true, false, false. And then our not Q, which is going to be false, true, false, true. And we're going to compare them and see if they match. So they don't match, they do match, they do match, and they don't match. So now this column is alive and in play. And the last thing we're going to look at here is the and. So we're going to combine them with an and. This is going to be true if both are true. So here they're not, here they're not, here they're not, and here they are not. So our final answer is this column right here. And you can see that it's false in every case. And so this is an example of a self-contradiction. All right, let's move on to our next special case, something called a tautology. And this is a compound statement that is always true in every case. Okay, so let's go ahead, fill in our cases. Hopefully this is becoming a little more natural for you. And then we start inside of our parentheses. We'll rewrite our P. We'll rewrite the Q. We'll join it with and, so they both have to be true. Now we can see this right here is alive. And now we want to negate it. So we're going to negate the yellow column here. So we just switch the truth value. It becomes false, true, true, true. And now this column is alive. We'll switch over, do this parenthesis, so we'll rewrite our P and our Q. Remember, or, the presence of true makes it true, so one or the other or both are true. So here we have a true, we have a true, we have a true, and we don't have a true, so that becomes false. So this one is alive right here. And we're going to compare these two, the two blue columns now, to find our final answer. So it's an or, meaning presence of true makes it true. So here, in the first case, we have a true. In the second, we have a true. In the third, we have a true. And the fourth, we have a true. And so our final answer is going to be this column right here. And you can notice that this is going to be true in every case. So this is a tautology. And what that means is it doesn't matter whether P or Q are true or false, this statement is always going to come out to be true. And so logically, we call this a tautology. Let's move on to an implication. So an implication is a conditional statement that is a tautology. So what it means is the final thing is going to be an arrow, that's the last column we're going to fill in, and we're going to have T's all the way down. And we just call it an implication. So here we fill it out. We'll get our 4 cases. Okay, so we have if P and Q, then P or Q. So we'll fill out our P, we'll just copy that down again. We'll copy our Q down again. So TF, TF, and they both have to be true. So here, they're both true. Okay, they're not both true. They're not both true. And they're not both true. So now this column is alive. And we're going to go ahead and find this parenthesis here. So we'll copy down our P's. We'll copy down our Q. And an or presence of true makes it true. So we have a true, we have a true, we have a true. Here we don't have a true, so it's false. And this column is alive. So now we're going to compare those two columns using our newly found conditional. I'll put this in our answer right here. So T arrow T, that's true. F arrow T, that's our grace case, and that's true. F arrow T is T. F arrow F is T. So you can see here that this is an implication because it's a conditional statement that is also a tautology. All right, moving on. So we want to complete some of these truth tables just for some extra practice and box the final answer column. First off, let's just do a little review. Does this sentence match the conditional statement? If the quiz is tomorrow, then I will not go out tonight. So if P, then not Q. Yes, it does match. So by coming up with all the different cases, we can then judge whether this statement is true or false based on what happened with P or Q. So I want you to go ahead and fill out this truth table. Go ahead and pause the video and come back to check your work when you're all finished. All right, welcome back. Go ahead and check your final answer here. Should have gotten false, true, true, true. If you didn't, go back through and try to see if you can figure out why the truth values are as they are. Let's move on to the next example. Once you go ahead and try number 2 on your own, pause the video and then come back when you're all finished to check your work. All right, welcome back. You can check your answer here to number 2. It should be this column. Should have gotten true, true, false, true, 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 true. Now, it turns out that we did a little more work than we actually needed to. If you look at this structure here, it says if P, then all this stuff. And you'll notice right here that this statement starts with a false in our P. Now, a conditional statement that starts with false will always be true. So it turns out we didn't need to do any of these because if our first statement is false, it doesn't matter whether this statement is true or false. So we could have done this and gotten an answer for our conditional statement. No such luck in number 3 though. We are going to have to fill out this whole thing. So again, I want you to practice this on your own. Go ahead and pause the video and come on back to check your work when you're finished. All right, welcome back. Go ahead and check your column here under the biconditional. Should have gotten true, true, false, true, false, false, true, false. Now, if you notice the comparison between these two, the only thing we had to check was the difference between conditional and biconditional. the Q or not R would have stayed the same. So we could have just kept this column here and then compared it with our P column. So be on the lookout for those things that are equivalent that are going to make life a little bit easier. All right, let's move on. In our last couple of examples, now we're just dealing with one row of the truth table, and they give us a compound statement, but they tell us the values of P, Q, and R. So again, all we have to do is substitute and solve one at a time. So Q is false. So we're going to put a false here. If and only if R is true. Okay, so then we have our conditional, not P, and P is true, so not true, or R is true, right here. So again, substitute in, then go ahead and answer this out. So false if and only if true, they don't match, so this is a false statement. We have our arrow, and then we have not true, which is false, or true. And so we have false, or if false, then false or true, that's a true statement. And if false, then true, that's going to equal a true statement. All right, number 5. Here we have a conditional statement that we want to tell whether it's true or false. So we say, if 3 plus 3 equals 8, then 5 plus 2 equals 11. So in this case, they don't tell us whether P and Q are true or not. We have to determine that based on the math. So does 3 plus 3 equal 8? No. So that's a false statement. Then 5 plus 2 equals 11. Well, 5 plus 2 equals 11. That is a false statement. Now, if false, then false is a true statement. So as odd as it seems, when we say if 3 plus 3 equals 8, then 5 plus 2 equals 11, we're saying a true statement. All right, I want you to try number 6 on your own. For these, you're going to have to determine the truth values of your P's and Q's and use those to determine whether the overall statement is true or false. So go ahead and pause the video. All right, welcome back. So for letter A, 15 is an even number, that's a false statement. 29 is an even number, that's false. And we have a conditional, if then. So false, if false, then false is a true statement. The next one, Orange Lutheran is a high school, that's a true statement. And, so we have a conjunction. Orange Lutheran is in Los Angeles, that's a false statement. The comma tells us to separate the left side from the right side, so we have parentheses. If and only if, so we get our biconditional. And then Orange Lutheran's mascot is a crusader, that's a false statement. So we just evaluate now. True and false is false, because they're not both true. And then false, if and only if false, those are matching, so therefore we have a true statement. Alrighty, so that's been truth tables with conditional and biconditional. Remember to go ahead and take your practice quiz in Milo Studio, and I look forward to seeing you all in class. Thanks again for watching.